Welcome to Hitachi Maxell Limited, Japan's leading maker of recording tapes, dry batteries, electric razors, and other products. Hitachi Maxell is headquartered in Ibaraki City in the Osaka Prefecture. The company has 3 plants in Osaka, Kyoto, and Kyushu. This is our head office, which is located in the Osaka plant. As you can see, dry batteries and silver oxide batteries are the main products of this factory. This is an aerial view of Maxell's Kyoto plant. Our Kyoto plant exclusively produces a variety of magnetic memory media, such as various kinds of recording, video, and computer tapes. Our Kyoto plant is located in the suburbs of Kyoto City, the ancient capital of Japan. It is surrounded by an excellent natural environment with clean air and pure streams. This factory produces magnetic powder, the original material of magnetic memory media, and all other processes leading up to the production of the finished products. The Kyoto plant produces roughly 3 kinds of products: audio cassette and open reel tapes, magnetic memory media, which are indispensable for information control and data processing systems, and videotapes, for which the demand is rapidly increasing. Let's now inspect the production processes of audio cassette and open reel tapes. This diagram will help you understand the overall flow of the production process. In the case of open reel tapes, the production begins by making magnetic powder. This is followed by the production of magnetic paint and the coating and slitting of the tape. In the case of cassette tapes, the assembly process follows slitting. All the products go through rigid quality controls in various production phases before shipment. We'll now explain the first half of the production process, from the creation of magnetic powder through the completion of the tapes. This is the structure of recording tape. It's basically very simple. It consists of a polyester base film coated with a magnetic powder. Let's now look at the inner structure of the magnetic layer, the most important part of a recording tape. Magnetic powder is mixed with various kinds of additives to improve its physical capabilities. It's then coated onto a base film with a high polymer resin bond called binder. In order for a tape to have excellent capacity, the magnetic powder must be small and clearly defined. It must also be shaped and oriented in one direction and evenly dispersed in the binder. We'll follow various production processes to show you how a recording tape is produced. These are the main materials which make magnetic powder. From left to right, they are alkaline liquid, ferrous sulfate, and water. These 3 ingredients are reactivated, mixed, filtered, and dried. The result is a ferric hydroxide. Ferric hydroxide is non-magnetic, so it is oxidized in this electric furnace to get a brown-colored magnetic gamma ferric dioxide. In the furnace, hydrogen gas is used to reduce ferric hydroxide, and oxygen gas is used to oxidize it. The result is the magnetic powder that is coated onto the plastic film. This is an automated panel that controls the entire process in the electric furnace. The operation is almost unmanned. The powder goes through a special treatment and drying. Then it's ready for coating. This is the first checkpoint. The magnetic powder is inspected under an electron microscope to make sure that particles are of the correct size and shape. These are electron microscope photos comparing magnetic powders of Maxell UD, ultra-dynamic tape, and another ordinary tape. All of the UD magnetic powder on the left is of similar size. The particles have a slender and sharply pointed shape. These features allow the UD tape to prevent noise and also to achieve outstanding frequency capacity. Now let's turn to magnetic paint production. In this process, we mix the powder with high polymer resin and solvent to make the magnetic paint that coats transparent plastic films. We mix various additives with the magnetic paint and combine them thoroughly in a ball mill. To achieve high-quality tape, the magnetic powder must be evenly dispersed in the binder. The completed magnetic paint is coated onto base films in a coating room after elaborate checks of its viscosity and other points have been made. In the coating room, it is essential that the atmosphere be free of any dust or contaminants. Workers wear special dust-free uniforms, and before they can enter the coating room, they take a shower from a blast of air. This is the transparent base film. Film sheets are extracted from the roll and coated with magnetic paint. This is part of a coating room. Coated tapes will go through a drying room and will be wound in a winding room. This coating machine has a precision that can adjust the coating thickness by 1/10 of a micron. After coating the film, we put it through a dryer and eliminate all solvents. The film is then evenly wound. We then recycle solvent waste with a giant device installed outside the plant building. The water is drained off, and the solvent waste will be reused and cleansed. The wound magnetic sheet rolls are temporarily kept inside a storage room under normal temperature and humidity controls before being sent to the next process. This is a calendaring machine, which is used to press magnetic sheets with a high temperature rule. During this process, the tape surface becomes even and its response at all frequencies improves. Now the tape is slit. After connecting a leader tape to the magnetic sheets, we cut the sheets into a predetermined width with a pair of rotating knives. The rotary blades cut the film into widths ranging from 9 to 50 microns, with a precision of 1/500th of a micron. A single slitting operation covers a sheet length of several thousand meters. The controls of the blades are elaborate and rigid. For the cassette tapes, slit tapes are temporarily reeled onto large hubs without flanges. We call them pancakes. These pancakes are reeled onto small cassette hubs in the following process. For open reel tapes, the slit tapes are directly wound up onto commercial reels, and they become the finished product. Finished magnetic tapes undergo severe checks. Inspections on their electric capacities are conducted on open reel tapes wound up into reels, and cassette tapes in the form of pancakes. Another check is also conducted on the magnetic characteristics of tapes. The curve shown is called the hysteresis loop. The tape for open reels is then packed and shipped. The tape for cassettes goes to the cassette assembly section of our plant. Here we see the basic parts of a Maxell cassette. Because we build the tape running mechanism into our cassettes, rather than having it installed in the tape recorder, cassette shells and parts must be made with an unusually high degree of precision to operate properly. This is how we make the plastic molding of the cassette halves. The metal dies have the highest degree of precision in current commercial plastic molding operations. We mold cassette shells of high-impact polystyrene that will not deform under high temperatures. Both the temperature and molding cycles are rigidly controlled. Tape from the pancakes is wound onto cassette hubs by automated equipment. The assembly of cassette tapes is almost all automated, which assures uniform quality. At Maxell, we use the screw fastening method to close our cassettes because it ensures their dimensional stability. These automatic screw closure machines exert a constant torque that eliminates warping of the cassettes. The machine applies 5 screws at the same time. The assembled cassettes then undergo strict checks on their external appearance and their function. The cassettes, after rigid inspections, are sent to the automatic labeling machine. Then they are housed in plastic cases, together with index cards, and wrapped in cellophane by the automatic packing machine. At this Kyoto plant, we not only produce recording tapes, but also conduct recordings onto cassette tapes. Using high-speed printers, recordings are conducted at a speed 32 times as high as normal cassette speed. The outstanding sound quality of these recordings is already appreciated by many people. The demand for videotapes is rapidly growing. We are exerting utmost efforts to give our videotapes long durability, as well as the capacity to reproduce fine images. Cassette tapes are easy to handle and are widely used in all parts of the world. To suit the customer's needs, cassette tapes must meet every kind of demand. In this inspection process, all kinds of conditions are applied to test the quality of our products. Running stability is vital to magazine-tight tapes such as cassette tapes and 8-track cartridge tapes. The tapes must run smoothly under high temperatures and humidity. Our plant has this special environment testing room to check the running life of tapes sampled out of mass-produced lots. As you can see, an Hitachi Maxell cassette, shown on the left, shows no distortion at all after being tested at the high temperature of 80 degrees centigrade. Compare that with the cassette on the right. The secret of Maxell's quality, reliability, and long life lies in the use of metal dies of the world's highest degree of precision, and in the rigid inspections and quality controls conducted every day. Here, an electron microscope is used to check a cassette shell on 170 points. This is a check for dimension through a powerful projector. This is an elongation test to check tape strength and stability. This is an inspection of plastic and labels under high-intensity arc lights, almost as strong as the sun. This is a vibration test for 8-track cartridge tapes to make sure they stand up under the constant jarring they receive in automobiles. Tapes passing final tests are put into display boxes for the first time. Their quantities are precisely checked here automatically. Completing the entire process, Hitachi Maxell tapes are put into cardboard cases and shipped all over the world. They reach audio fans on all parts of the earth and give full play to their outstanding qualities.